The problem is, you want to distill a feed of 50% saturated vapor containing 30% N-pentane and 70% N-heptane, for which vapor-liquid equilibrium data are given. The overhead should contain 95 mole percent pentane and the bottoms 10 mole percent pentane. The reflux ratio should be 1.3 times the minimum. A. How many ideal stages are required? B. On which ideal stage should you feed the vapor? And C. Sketch the effect on the equilibrium line of a Murphree efficiency of 67%. To easily analyze the problem, I will first illustrate the distillation process and its given. D is for the distillate and XD is equal to 0.95. B is for the bottoms and XB is equal to 0.10. F is for the feed and XF is equal to 0.3. We know that these X compositions are based on the more volatile component, which is the pentane. And since the feed entering is 50% saturated, Q is equal to 0.5. First, I will write an overall mass balance in the system. So F is equals to B plus D. And this will be our first equation. Then, I will write a mass balance for the pentane, which is 0.3F is equals to 0.10B plus 0.95D. And I will assign it as equation 2. Combining these two equations, we found that B is equals to 0.765F and D is equals to 0.235F. Using the feed line equation and substituting the necessary values, this can be simplified as y is equals to 0.6 minus x. We need to find the minimum reflux ratio. To do that, we must know the feed line intercepts with the equilibrium line. The equilibrium line is given by the equation in terms of alpha. Alpha will be solved from the given vapor-liquid equilibrium by using the formula alpha is equals to y1x2 all over y2x1, and then get the average. Equating the equilibrium line and feed line equations, we can get their intersection points at 0.113 and 0.487. Thus, the minimum RD is 1.24, and this will give the reflux ratio RD, which is 1.3 times the minimum. So, RD is equals to 1.612. Using operating line equation of rectifying section, substituting the values, we can simplify it as y is equals to 0.364 plus 0.617x. Equating the operating line and feed line equations, we were able to get their intercepts at point 0.146 and 0.453. From the Excel file that we made for Mccabe Thiele with Murphree efficiency, I entered the values from the problem. XD is equals to 95%, XF is equals to 30%, XW is equals to 10%, Q is equals to 0.5, and Murphree efficiency is equals to 0.67. I used the given vapor-liquid equilibrium to solve for average alpha. And this is the value that we will enter for alpha. From the earlier discussion, we were able to get the minimum reflux ratio, which is 1.24, and R will operate 1.3 times the R mean. So it will be equal to 1.612. We can also solve our mean by employing this formula. And the notation is this. Basically, we will get about the same R mean. And this is now our final diagram for the problem. For you to clearly see the number of ideal stages, I will just remove the equilibrium line of a murphree efficiency. So there you go. Counting for the ideal stages, we have 1, 2, 3, 4, and 5. This will be the answer for letter A. From the figure, we can see that the vapor should be fed at the fourth stage. For the Murphy efficiency of 0.67, the equilibrium curve is moved downward as the broken line shows.